on Friday, and we're going to practice for it right now. So if you get out that same packet that we were working on yesterday, that little review thing, the second page of it actually is a practice quiz. So we're going to do all three. There's actually 3 practice quizzes. We're going to do all 3 of them. And the quiz you take will look just like these. Okay, so we want to pay real close attention and see if we can do these problems. So I'm just going to do, I didn't number, oh yeah, I guess I did. So this is the first one. We're going to do this one. It says simplify. This right here. We did some of these yesterday. Who remembers our strategy when we have like a string of stuff here?
Cancel,
Okay, so let's talk about that. If you are multiplying, which we are, and you notice that you have reciprocal functions, yes, they will cancel out. Does that make sense to everybody? Tangent and cotangent are reciprocals. They're like 3/4 and 4/3. Whenever you multiply reciprocals, they cancel completely and make 1, right? So if you notice that, you absolutely can do that. Now, sine and secant are not reciprocals. So what do you want to do with those two? So if it's a sine or a cosine, we just put it over 1. We don't change it. But what is secant? 1 over cosine. Now when I multiply these, nothing here cancels. So I have to just multiply them straight across. So what am I going to be left with? Sine over cosine, which is tangent. You will have your colored sheet tomorrow, or you will have a colored sheet tomorrow. Okay? So you might already have that one memorized because we use it a lot, but if not, that one's on your sheet. All right, everybody okay with that? If you didn't notice that those canceled, you would change this into cosine over sine, and that into sine over cosine. And now do you see why they cancel? They're going to cancel out one way or the other. You can just save yourself some writing if, like Geo, you notice these are reciprocals. Okay? Now, do we cancel every time we see a tangent and a cotangent? Only if they are multiplied. Okay? Then we cancel. All right, how about number 2? Anybody notice anything about this one? I know we talked about this yesterday. You can change thetas to x's if it's easier. I don't want the theta to confuse you. Scout?
They're the same.
What?
Did they both equal sine? Like
Careful.
it's just 1.
The numerator is
Sine.
sine squared. Remember, 1 or no. Sine squared plus cosine squared is 1. That's the identity. That's the formula. If we subtract the cosine squared over to this side, doesn't it say sine squared equals 1 minus cosine squared? Guys, you need to know that, okay? You need to be familiar with that. That sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared, because of that identity right there. So when I see, or when you see this numerator, you're immediately going to think, oh, that's sine squared. Not sine, sine squared. So we have sine squared over sine. And what happens when we have sine squared over sine? one of them's gonna cancel out, and the answer to that is. All right, on the back side of that is another practice quiz. So let's take a look at it. Does anybody have a thought on the first problem when you look at it? And again, if you don't like the thetas, make them X's.
1 plus 10 squared equals 6.
Edgeny says the denominator is on my formula sheet. The denominator is just secant squared. Is that right? You okay with that? So what does that mean? What happens now? You can cancel, but be careful when you cancel. What are you gonna be left with? 1 over secant. And what is another better way of writing 1 over secant? Cosine. Remember, secant and cosine are reciprocals. So 1 over cosine is secant and 1 over secant is cosine. This to this right here is directly on your sheet. Would you agree with me? Directly on your sheet. You just wrote it down, didn't do anything tricky. And then you just had a simple little cancel. All right, number 2. You've got cosine squared, sine, secant, and tan. All right, what do you want to do with this? It's all multiplied. Okay, now, Edgeny's getting a little bit sophisticated here. She says cosine and secant are reciprocals. What do we know happens when we multiply reciprocals? They cancel, but be careful. There's actually 2 cosines. So if you want to do that, you can, but you're only going to cancel out 1 of the cosines. Now, you don't have to do that, but if you notice that and want to do that, you certainly can. What now? This is now cosine over 1, sine over 1, and sine over cosine. Anything canceled? Cosine. And what are we left with? Sine squared. Now, that problem is, that's exactly right. If you can do that, that is perfect. You could also have not done that canceling in the beginning and simply written your problem as a bunch of fractions right off the bat. And then canceled. Okay, so got 2 cosines here and 2 cosines here. Are we left with the same thing if we do it that way? Are we left with sine squared? Yeah. So whatever you're comfortable with. With these problems that are all multiplied, you can right off the bat change everything into a fraction, make it sine over 1, cosine over 1, and change everything else. Or, if you notice reciprocals, you would cancel them before you get started. Okay? All right, we got one more practice quiz. All right, let's have you try this one. Go ahead and see how far you can get with it on your own. Both problems. Go ahead and try both problems. fix you get one, you can bring it up and put it on the board if you like. Get attendance taken. Got one? We're gonna laugh hysterically if you're wrong. But I'm sure you're not gonna be wrong. So Gabe's doing the first one, if there's anybody who wants to try the second one. Well, he did that pretty fast. Anybody wanna agree or disagree with him?
That's what he's saying, instead of one.
One over cosine is fine, but you could put secant, absolutely. Isn't one over cosine secant? You do not have to do that. The general rule of thumb is if you get it reduced down in terms of sine and cosine, it's okay. It is a little simpler, I think, simpler expression to just write secant, but one over cosine will be full credit, 100%. But that is secant for sure. Did he do okay? Is that all right with everybody? Notice, hasn't every practice quiz had one problem on it that was like this, where you had all these things times each other? That's the way your quiz will be. You will do one problem, just like the one Dave just did. Is everybody okay with that? Taylor, you okay with that one? All right, now let's look at this next one. It looks a little scary, but I want you to think about the problems that we've practiced the last 2 days. What are some of the things that we've done? Some of the strategies we've used to get started. Like we foiled. Yesterday I remember there were 2 problems we foiled. Well, this isn't a foil situation, but what could I do here? I could factor out a sign. This has a sign, and this actually has 3 signs, so I'm going to take a sign out. What will I have left if I take a sign out of here? 1. Yep, remember, if you take out the whole thing, you have to put a 1. What will I have left here? Sine squared. Okay, wait a second. We have seen this before. What is 1 minus sine squared? Cosine squared. Because, I'm going to write this one more time, but we keep running into this idea, so it's something you probably ought to know. That's on my formula sheet. But I can rearrange things. I can bring this over here, so it says cosine squared equals 1 minus sine squared. 1 minus sine squared is cosine squared. 1 minus sine squared is cosine squared. 1 minus cosine squared is sine squared. Guys, got it? Those are special. Those are important. You need to remember those. So if this is the same as cosine squared, I'm going to go ahead and write it as cosine squared. So this guy right here in orange is the same as cosine squared. So I'm going to substitute in cosine squared. What good was that? What's going to happen now? What's going to happen now? I'm going to cancel out one of the cosines. So what am I going to be left with as my final answer? Sine times cosine. Now sine times cosine is nothing, so you just leave it sine times cosine. If it came out to be sine over cosine, then you could make it tangent. All right, so on Friday morning, we're going to have a quiz. It will have 2 problems. One of the problems will be like Gabe's, and one of the problems will be with the squares. All right. If you are still a little apprehensive about it, recopy these practice problems on another sheet of paper and see if you can work through them again by yourself. That would be really good, actually, to do that. Because I won't be here to coach you. Okay, all right, let's get our notes out. And we're gonna work a little bit in section 5. By the way, you'll need a calculator now. For the rest of this whole chapter, we need a calculator out every day. Set in degrees. Put these away. These are your practice tests. You're all here today, almost. Put them someplace. Here. Today we're going to start the law of sines. You want to redo these homework problems as you prepare for your So again, I know Friday you're gonna miss most of the day, but you're gonna miss the whole day except the first part of alpha. So we will have class and we will have our quiz. So count on that. Okay. Now, our job is to solve this triangle. You're gonna like this. This is easy. Compared to what we've been doing, this is a cakewalk. All right, so first of all, when I label a triangle, the angles get capital letters, A, B, C. The triangles get capital letters. And notice I label them outside the triangle. So A is out here, B is out here, C is there, okay? And the sides get lowercase letters. So across from side, or angle A, across from angle A, this is side A. This is side B, and this is side C. That's just kind of like the standard way of labeling a triangle. So wherever angle A is, side A is across from it. Okay? And so on. To solve a triangle, like these directions say solve, means find everything that's missing. So what's missing? Well, what's missing is angle B. I don't know what angle B is. I don't know what side B is. And I don't know what side C is. Those are the missing parts of the triangle. A triangle has 6 parts, 3 sides, 3 angles. You will always be given 3 of those parts and have to find the other 3. Now, you actually did this sort of on your test. You didn't find everything, but you found like side B or something before on our word problems. Didn't we find side B or whatever the height, whatever the tree, whatever? But we always used SOHCAHTOA because our triangles were always right triangles. You know, the flagpole standing and the tree standing and all that. This is not a right triangle. So SOHCAHTOA won't work, and the Pythagorean theorem won't work. Those are wonderful tools, wonderful, wonderful, wonderful. Use them all the time, but they only work if the triangle has a right angle, 90-degree angle. So I'm not going to use SOHCAHTOA in this problem. Is there anything you can tell me before we get started, though? Is there anything you can tell me about any of these? Can you figure out any of those just based on what you know? We know the angles of a triangle have to add up to 180. So if I know 2 of them, then finding the third one shouldn't be too tough. What is angle B? 72. So B is 72 degrees. Okay, done. That was easy. Now, no SOHCAHTOA. Instead, we use what's called the law of sines. And the law of sines says, it's very easy, sine A over A equals sine B over B equals sine C over C. The law of sines is just a giant proportion. Sine angle over its side, sine angle over its side, sine angle over its side. Kamari, you need to wake up. If you're ill, we'll send you to the nurse. Otherwise, I need you to be awake and alert. Okay? So, let's look at what we've got. Do you see right here, I call this a pair. I know angle A, and I know side A. So that's what I start with. Sine 38 over 16. That's what I start with, the pair that I know. Okay? Now, that's going to equal another pair. And you can do either B's or C's. It doesn't matter. The order that you do things doesn't matter at all. So we have sine 38 over 16. What do you want to set that equal to? It doesn't matter. Pick one. B. Sine 72 over B. Sine 72 over B. Now, is that solvable? Is that something I can solve? Yes. by cross multiplying. So B sine 38, B times sine 38 equals 16 times sine 72. Now I want B, so aren't I going to divide by sine 38? So what's going into the calculator? B is going to equal 16 sine 72 divided by sine 38. Is everybody with me on that? Little caution, first of all, make sure you're in degrees. All of our work will be in degrees, so you won't have to be changing it. We're going to do everything in degrees. When you type this in, when you hit 16 sine, a parentheses automatically comes up. That's fine. Type 72, but then close the parentheses before you hit divided by sine 38. So 16 sine 72, close parentheses, divided by sine 38. And did you get 24.72? Okay, so that was B, 24.72. All right, we're almost done. We just have to find C. Any ideas how we'll find C? Same way we found B. Back to what you know, sine 38 over 16. And this time, sine 38 over 16, this time set it equal to sine 70 over C. Isn't that easy? Law of sines. It's a breeze. There's one little thing about it that's tricky we'll talk about, but for the most part, it's a breeze. So C sine 38 equals 16 sine 70. I'm just cross multiplying. C times sine 38, 16 times sine 70, and then I'm going to divide by sine 38. And again, when you type it in, make sure 16 sine 70 close parentheses divided by sine 38. 24.42. These didn't exactly match, but they're awfully close. Can anybody figure out why these two answers are so close to each other?
Because the degrees are close.
Because the angles are close. That's right. Remember, the bigger the angle, the bigger the side. So if the angles are almost the same, then the sides are going to be almost the same. How about that? Your first law of sines problem. Everybody good? Ready for the next one? Okay, B looks about the same. Different letters on the triangle, but that doesn't matter. The letters used don't have anything to do with it. So this is 71, this is 48, and this is 8. All right, so make sure that you get things labeled right. Here's angle E. So this is side E. This is angle F. So this is side F. And obviously that's angle B. So those are our things that we have to find. All right, so what's your thought about proceeding with this problem? Kendrick, What do you think? We'll look back at the one we just did. What did we do first? This is just like that problem. So what did we do first? What did we figure out first?
I would say sine 30 or sine 48. Or 5%.
Can you find that angle right there? I need that angle. Okay, I gotta have that angle, so we're gonna let Kendrick find it. He's gonna figure it out for us.
This
61? Yep. Remember, you have a calculator for everything. So, all this, total calculator. Everything's calculator. So everybody good with 61? Now, as soon as he found that 61, remember, when you do the lost signs, you gotta look for this pair. Do you see it? You have to have a pair for the lost signs to work. So the pair you have is sine 61 over 8. All right, Taylor, what can we set that equal to? We've got sine 61 over 8. What do you want to set that equal to? What?
48.
Well, you would say sine 48 over E. Sine 48 over E. Okay? All right, let's cross multiply and solve, see what we can come up with. And when you're cross multiplying and dividing, put down as many steps as you need. The more of these you do, the more efficient you'll become. Ayrton, you got an answer? Yep. So E is about 6.8 when we round it off. Everybody else get that? Those of you not typing along with us, you will be the ones that miss points on the test because you don't know what you're doing. So everybody should be typing these in. All right, we're almost done. We have one more thing to find. Who's got a plan for that? RJ, what do you think? We're gonna find F. Yep, we're gonna find F. All right, we're gonna go back and do what we just did. So what did we do to find E? Always go back to your pair. So we'll start with sine over, okay, so that's what we start with. Sine 61 over 8. And this time, since we're looking for F, we'll set that equal to sine 71 over F. Yep. All right, let's do our cross multiplication and all that stuff. answer. Yep, I got 8.65. Everybody else get that? All right, one more. This time though, I didn't draw the triangle for you. Look at example C. I didn't draw the triangle. All right, can you draw the triangle? Sure you can. And here's the good news. It doesn't matter, it looks like our letters are gonna be A, B, and C this time. It doesn't matter where you put your A, B, and C. They can go anywhere. Just remember that if you put A here, then this is gonna be side A down here. So I don't care where you put your angles, but wherever you put your angles, that's gonna determine how you label your sides. All right, so I'm just gonna do A, B, C this way. So that means this is my B and this is my C. I need everybody to make sure you're clear on that. If you put your labels in the wrong spot, then everything won't work out right. Everybody good? With your setup. All right, so let's fill in what I know. I know angle A, remember capital letters are angles. Capital letters are angles. So 42 is an angle, 73 is an angle, and side A is 6. So this time we're finding angle C, side B, side C. Jocelyn, where are you starting with this guy? What are you gonna do first? Sine 42 over 6. She says right here, I have my pair. Oh, shoot, my pink markers. Right there's my pair. Everybody see it? So she says sine 42 over 6. All right, what are you going to set that equal to, Jocelyn? Perfect. Sine 73 over b. Did Jocelyn set up her law signs correctly? She absolutely did. So let's solve it. And Kaden, I want you to tell us what B is this time. What side B is? Side B. I think. Anybody get 8.58 like Caden and I did? And that was side B, perfect. Beautiful. Sydney, what should you think, or what do you think we might want to do next?
180 minus 42 minus 73.
So Sydney says I could find that third angle. We could have done that first. We didn't need to, so she didn't. Jocelyn didn't, which is fine. But now we really need it. So what is it? 65 degrees. All right, everybody good with 65 degrees for angle C? Okay. All right, now side C. Mari, set it up for me. What's my setup gonna be to find side C? We're finding side C. No. Here, always start with your pair. So we're gonna say sine 42 over 6. Sine 42 equals sine, in this case, we want C, so we'll do 65 over C. So always start with what you know, your pair. So sine 42 over 6, and then in this case, sine 65 over C. Okay? Alrighty. Let's cross multiply, and Brennan, I want you to give us the answer this time. Okay, let's talk about that. That's not what I got, and let's talk about that. He said he got 3.63. Now, you can tell, hopefully, yourselves by looking at this, that that answer can't be right. Can anybody explain to me why that side of the triangle can't be 3? This is the smallest angle, right? And his side is 6. The smallest angle has the smallest side. So if the smallest angle already has a 6, then another angle cannot have a, try it again. So you're typing in 6 sine 65, close parentheses, divided by sine 42. I got 8.13, yep, 8.13. So did you figure out what you were doing wrong? Okay, but that was a good thing to have happen, because that might happen to you if you press the wrong button or something. Pay attention. There's no way that side could be 3. It's 8.13. Okay? Now, I told you earlier, there is one, the law of signs, everybody loves it, it's easy. But there is one glitch with it. Alright, and we're going to do one problem involving the glitch. There are others. We have a bunch of examples, it looks like. But we're going to do number or letter A, 2A. So we talk about what the glitch is with the law of sines. So here's my triangle, ABC. Angle A is 20, side A is 12, and side B is 31. Now, does my setup make sense to everybody? That fell off earlier, so. Does my setup make sense to everyone? Everybody okay? All right. Does everybody see this pair right here? That's my law of sines. When you see that pair, you immediately think, oh, law of sines. So sine 20 over 12. What's it going to equal, though, this time? Gio?
Sine B.
Exactly.
Over 31.
Sine B over 31. So kids, this is a little bit different now. We're looking for an angle. Let's go ahead and cross multiply. 31 sine 20 equals 12 sine B. Now this can't be split up. That does not separate, ever, ever, ever. So, we're gonna divide both sides by 12, I guess. So 31 sine 20 over 12 equals sine B. Now, you've done problems like that before. I want you to think about the squirrel in the top of the tree looking at a nut on the ground, and you had to find the angle of elevation, and maybe this was 10 and this was 20, and you said tan x equals 20 over 10. Remember that? How did you find your angle? What do we have to do on our calculator to find an angle? Second. So what you're typing into your calculator now is second sine this fraction. So if you are solving for an angle, if your variable is the angle, we have to second sine, and it'll always be second sine in law sine, so second sine. All right, and we just type it in, don't panic. Second sine, these parentheses automatically come in. 31 sine 20, close the parentheses around the 20, divided by 12 equals, what did you get as your answer? 62.07. So 62.07. What? Gio?
Can you round up, or is it just on 62.0?
I think we're always gonna be rounding to the 100, so we're gonna say 62.07, yeah. Wait, we're not done, guys. This is the tricky part. Did you notice what the directions to this problem were?
How many triangles?
How many triangles are possible? Sometimes when we do the law signs and we're finding an angle, B is our variable, sometimes there can be more than one answer. If there is another answer, in other words, there could be another angle B. There could be a different angle B, okay? If there is, it's 180 minus the first one. So since my first one was 6207, my second one will be 117.93. I second sign to get my first answer. If there is a second answer, it's just 180 minus the first one. That triangle is fine. Those add up to less than 180. So there are two triangles possible for question number 1. We'll talk more about that on Friday, but that's it for now.